In this video, we are going to graph and analyze this rational function. One of the first things I'm going to do is to factor this, just in case. And if I factor this, there's nothing I can do with the numerator, so I just write down 2x minus 5. The denominator is the difference of two squares, so that will factor as x plus 4 and x minus 4. I notice that nothing will cancel out. That tells me that there are no holes, so I can just go ahead and put none for that. Now I will skip the domain for a minute because first I need to know the vertical asymptotes. So the vertical asymptotes come from setting the denominator equal to 0. So if I were to set this denominator equal to 0, I would wind up setting x plus 4 equal to 0 and x minus 4 equal to 0. But that would give me x equals negative 4 and x equals positive 4. So those are my two vertical asymptotes. I'm going to go ahead and graph those. All right, you should graph your asymptotes as a dotted line, of course. Okay, so I have one at positive 4. And I have one at negative 4. Okay, so those are the two vertical asymptotes. And since there are no holes and I've got my vertical asymptotes, I already can tell what my domain is going to be. Because the function is going to approach from the left, so the function is going to exist from negative infinity to negative 4, and then it's going to run from negative 4 to positive 4, and then there's an asymptote, and then they will pick up and go from 4 to infinity. Even before I graph it, I know that the function is going to run from negative infinity to positive infinity, except for the vertical asymptotes. And it'd be the same if there had been any holes. So I know the domain will be negative infinity to negative 4, union negative 4 to positive 4, union 4 to infinity. Okay. Let's find the horizontal asymptote. So the horizontal asymptote depends on the degree of the numerator and how it compares to the degree of the denominator. If the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is y equals 0. If the degree of the numerator is is equal to the degree of the denominator, then the horizontal asymptote is y equals a over c, where a and c are the leading coefficients. And if the degree of the numerator is greater than the degree of the denominator, then there is no horizontal asymptote. So the degree of the numerator here is 1. I see the plane x, that's sort of like having x to the 1 power. Meanwhile, the degree in the denominator is 2. So I have degree 1 and degree 2. So since the degree of the numerator is less than the degree of the denominator, then y equals 0 is my horizontal asymptote. So I can go ahead and write down y equals 0 for my horizontal asymptote. And let's go ahead and graph that as well. Okay, y equals 0 is the x-axis, so there you go. There will be no slant asymptote because you get a slant asymptote only when the degree of the numerator is exactly 1 greater than that of the denominator, 1 greater. And here the degree of the numerator was less. So no slant asymptote. So we can go ahead and write none. All right, let's find and plot the y-intercept and the x-intercept. You will get the y-intercept if you plug in 0 for x. Okay, so if we let x equal 0, that's how we can find the y-intercept. Okay, that's usually easy to do just by glancing at the function. So I'm letting x be 0. So imagine that I put in 0 for x right here. And what if I put in 0 for x right here? Well, in that case, what happens is, let's see, let me pick a dark color. All right, because I put in 0, then this term is gone. And I put 0 here, so this term is gone. So that only leaves these two terms, the -5 over the 16. A negative divided by a negative is a positive, so that's really 5/16, which doesn't reduce any more than that. So that is my y-intercept, which you can really do at a glance. So my y-intercept is 0, 5/16. Now, if you were even slightly uncomfortable with that analysis, you could check your answer by using your TI-30 XS multiview. If I type in the original function, so 2x minus 5 is in the numerator, and then what was it? X squared minus 16, I do believe. Okay, if I put 0 for x, then the calculator is going to evaluate the function for me, and there's that 5/16 that we found by hand a moment ago. So if you know what you're doing, it's actually easier to do by hand. But if you don't, hey, use your calculator. Now, x-intercepts. As long as there's no number hanging on the end here, we can find the x-intercept by setting the numerator equal to 0. All right, I'm going to let the numerator equal 0. So in this case, that means setting 2x minus 5 equal to 0. All right, is there any space for me to work this out somewhere? Oh, here we go. All right, if I set 2x minus 5 equal to 0, adding 5 to both sides, I'd have 2x equals 5. Dividing by 2 on both sides, I'd have x equals 5 over 2. So that is going to give me my x-intercept. Okay, so my x-intercept is going to be 5 over 2, comma, 0. Now, let's go ahead and graph both of these points. So 5/16 is 0.3. All right, so keep that in mind as you graph it. Okay, that this is approximately 0.3. So 0, 0.3 okay, is going to be right about here. Okay, now 5 over 2 is, of course, 2.5. All right, so this is like having 2.5, comma, 0. Okay, so I'm going to go over 2.5. On the x-axis. Okay, so 2.5 is going to be right about there. Now, notice that there is an x-intercept, even though there's a horizontal asymptote here. A lot of kids think that you can't touch the horizontal asymptote. That's true for vertical asymptotes. You will never find a point that's on a vertical asymptote because vertical asymptotes happen because you can't divide by 0. But horizontal asymptotes are really all about the end behavior. So in the middle area, the horizontal asymptote gets touched and crossed over all the time. So don't let that bother you. Okay, so I have these 2 points, and now it is time to solve the rest of it. I need some additional points. Well, you know what? Now would be a good time to go ahead and say the end behavior, because I mentioned that the horizontal asymptote is really there to tell you about the end behavior. So if you know that the horizontal asymptote is y=0, you know that the end behavior is going to be approaching 0 on the left and the right, 0 and 0. If this had been y=2, it would have been 2 and 2. So we'll go ahead and graph it, and then you'll see that as we go to the left towards negative infinity, the graph will in fact approach 0. As we go to the right, the graph will approach 0. But we know that even before graphing it, it's always going to approach the horizontal asymptotes on the extreme left and the extreme right. So to actually do the graph, we need some additional points. And here's what you do. To pick which values to put on your table, I recommend using your vertical asymptotes. So we have a vertical asymptote of -4. Okay, so imagine putting that on a number line. Okay, -4. So for every vertical asymptote, you're going to get 4 values to put on your chart. So my first 2 values I will get by going to the left and right of -4. To the left of -4, I'm going to have -5. To the right of -4, I will have -3. So I'm going to have those 2 values. But also, halfway in between -4 and -5 is -4.5. I want that too. Halfway between -4 and -3 is -3.5. These are the 4 values I'm going to put on my chart because of this vertical asymptote. So I'm going to have -5, -4.5. So how many? I got 1, 2, 3, 4, 5, 6. I need some more spaces on this chart. Oops. Mayday. Okay. All right, so I really should have 8 spaces on this chart. So, okay. Now, so like I said, now I've got my -3.5, and I've got my -3. Okay, now we have another vertical asymptote at +4. So I'm just going to do the same thing. So I've got +4. So I'm going to go to the left and to the right. So to the left, I've got 3. And to the right, I've got 5. Between these is 3.5, and between these is 4.5. Okay, so I'm going to put those 4 values on my chart. So I've got 3, 3.5, 4.5, and 5. So these are the 8 values that I would use. Now I'm going to use my calculator to evaluate these. Okay, I already have my equation in the table, but instead of being in auto mode, I'm going to make sure I'm in ask mode, ask X. And what am I going to ask X? Let's see, -5, -4.5, -3.5. So I need -5, -4.5, and -3.5. Okay, these are pretty ugly looking. For graphing purposes, I really need decimals. So this is negative 1.7 if you round. Okay, this is negative 3.3. And this is 3.2. Okay, in a similar way, I'm going to keep going and I will find all of the y values that go with these x values. I'm going to do that off camera because I think you get the idea. Okay, so these are the values that I get from my calculator. So I'm going to take each of these points and I'm going to plot them. So I will plot a couple of them on camera and then I'll just do the rest off camera. Okay, so I've got negative 5, negative 1.7. Okay, so that's going to be negative 5 is at negative 1.7 would be about here. Negative 4.5 is at negative 3.3, which is about here. Negative 3.5 is at 3.2, which is about here. Okay, and negative 3 is at 1.6, so this is negative 3, and this would be about 1.6. Uh-oh. Okay. Let's see, positive 3 is at negative 0.1. Okay, so positive 3 is just about here. Okay, what's next? 3.5 is at negative 0.5, so that's right about here. 4.5 is at positive 0.9, so that's about here. Okay, and finally 5, can I get this point? Come on, little guy. 5 is at 0.6, so that's a little bit lower. Okay, I said I was just going to graph a couple of them, but then I went ahead and graphed them all. So there you go. Now these points should be sufficient to give me an impression of where the graph is going. So I'm going to sketch the curve passing through these points and making sure to approach the asymptotes on the ends. So if I do that, so it's got to approach the asymptotes. It's got to go through these points and then approach the asymptote. So I know that was a little crooked. It's really tough to do this with an electronic pen, and it disappeared anyway. I might have to do this off camera after all because I forgot about how it disappears. So it should look something like that. Now this one, notice I have points above the horizontal asymptote and below the horizontal asymptote. Okay, that tells me that the graph passes through the x-axis and then goes down. So it's going to approach this vertical asymptote. All right, it's going to pass through these points. There's my x-intercept. And then it's going to approach this vertical asymptote. All right, meanwhile, I'm going to have a branch over here that's got to approach the asymptote, pass through these points, and again approach the asymptote. Now it looks like it's touching these asymptotes, but in your mind you have to understand that it's getting closer and closer to the asymptote, but it really actually doesn't ever touch the asymptote. All right, so that's what your graph should look like. Notice what I said about the end behavior. On the far left, it's approaching the horizontal asymptote, of course. It's approaching 0. And on the far right, it's approaching 0. So this is the far left, and this is the far right. And that's it for problem number 7.